Okay, this is another Higgs Boson video, and it's E-TTL, Neutrino Oscillations, Higgs ICARUS, Detector, Dodecahedron, Leonardo Da Vinci. I started working on the data September 29th, and today I'm filming it on November the 16th, 2012. This data is from the August 20th video titled Part 1, Atlas Inverse Matrix Higgs Boson Mass Tevatron Cofactor E-TTL Diphoton PP collisions. This is part 2, which is this video here. And the next videos about Leonardo Da Vinci have been separated into another series for me to work on in the future. So E-TTL neutrinos. So these are different links that I found when I googled this word. Neutrinos and Cables came up by blogs.discovermagazine.com by Sean Carroll, February 22nd, 2012. Not that there's much chance that neutrinos are actually moving faster. This is up to the fiber through a TTL to fiber converter. The type is just a, okay, so he's talking about that. Terrestrially enhanced neutrino oscillations from links.aps.org. And that's from E.D. Carlson, 1986. You can see the keywords are neutrino, and it's got different measurements there. And then the theory of weak interactions with continuous spin neutrinos, links.aps.org. GJ inversion, 1970. Lepton numbers are conserved if all the neutrinos and antineutrinos are distinct. Mental upper bounds on the neutrino masses. Neutrino scattering and new particle production, www.annualreviews.org. From D. Klein, 1977, talks about the cross sections of quasi-elastic scattering of neutrinos and I think just experiments. And then there's the Google link. Black diamond neutrino carabiner, there's a link to that. A PDF file came up, measurement of the neutrino velocity with the ICARUS detector, and that's arxiv.org. And that's 2012 from PASJ Saranaj in March 2012. And it talks about the Department of INFN, University. So there's another link there. And then so I Google ICARUS detector to see what it looks like, and this is what it looks like. Picture here, schematic representation of a single module of the ICARUS detector and its functionality. This is charged particles, track drift of electrons, cathode, and TPC wires. You can see that there. So it's from icarus.ings.infn.it. And quote, the ICARUS detector, this would be from this website. The ICARUS detector is composed by two semi-independent symmetric filled with liquid argon modules of approximately 3.6 by 3.9 by 19.9 cubic meters. The charged particles passing inside the volume, whereas a uniform electric field is applied, produces ion-electron pairs. And that's from icarus.ings.infn.it. Okay, detectoroverview.php. So quotes from Wiki, ICARUS imaging cosmic and rare underground signals is a physics experiment aimed at studying neutrinos. It is located at the Laboratorio Nazionale del Gran Sasso, LNGS. The keywords are liquid argon time projection chamber, which is LARTPC, CERN neutrinos de Gran Sasso, CNGS, and superproton synchrotron from CERN. The CNGS neutrinos are also studied by the OPERA experiment. Therefore, those experiments are also called CNGS-1, OPERA, and CNGS-2, ICARUS. Measurements of neutrino speed, quotes from Wiki, measurements of neutrino speed have been conducted as tests of special relativity and for the determination of the mass of neutrinos. Since it is established that neutrinos possess mass, the speed of neutrinos should be slightly smaller than the speed of light, according to special relativity. Existing measurements provided no deviation from this prediction within the margin of error. And this is speed m to s and kinetic energy EV. So that's what that graph says. So neutrino speed as a function of relativistic kinetic energy with neutrino mass of less than 0.2 eV c squared. Data and diagrams from Wiki. Keyword from neutrino data is Lorentz covariance, boost of velocity in spacetime. And here's a geodesic triangle on the sphere. The geodesics are great circle arcs. And then construction of a dodecahedron basing on a cube. Dodecahedron in this shape here. So September 25th. This looks like the cube for the middle of the spaceship core with the round look to it. Interesting, I'm working on a UFO theory, and Leonardi Da Vinci is connected to one as well with this dodecahedron drawings and UFO paintings, which I'll explore in another set of videos. Okay, so that'll go into another series. I'll let you know when I get there. So the formula keywords from data are neutrinos, cables, cosmic variance, fiber, TTL, oscillations, conversion, solid angle, weak interactions, continuous spin, neutrinos, lepton, neutrinos, antineutrinos, neutrino masses. Upper bounds, quasi-elastic scattering, black, diamond, I think that's supposed to be diamond, neutrino carabiner, so I'm going to Google that to see what it means, and measurement of neutrino velocity in ICARUS detector. Symmetric liquid argon modules, cubic meters, charge, particle, volume, uniform electric field applied, produces ion electron pairs, ICARUS, imaging cosmic and rare underground signals, experiment, studying neutrinos, LNGS, Laboratory Nazionale del Gran Sasso, liquid argon time projection chambers, CERN neutrinos to Gran Sasso, superproton synchrotron from CERN, Opera experiment. CNGS1 is Opera and CNGS2 is ICARUS. Measurements of neutrino speed. Measurement, neutrino speed, tests of special relativity. Determine mass of neutrinos, neutrinos pass mass, speed of neutrinos. Smaller than speed of light, according to special relativity. Existing measurements, no deviation. Predictions, margin of error. Graph, neutrino speeds, function, relativistic kinetic. Energy, a keyword brought up a lot in the WOWS data. Neutrino mass less than plus or minus 0.2 eV c squared. Lorentz covariance, boost velocity, space-time. Geodesic triangle, sphere, great circle arcs, dodecahedron, cube, UFO core, Leonardo Da Vinci, paintings, sketches, UFO designs. We're going to see those in the next videos. September 30th. My thoughts. The keywords from the formula. The first time reading this, neutrinos pass mass, I didn't know that. I know they are supersymmetry and mimic other particles, and now they pass mass just like the Higgs field does to the Higgs boson particles and other particles. Interesting. Continuing the rest of the data in the next video. Neutrinos, mirrors, Higgs mass particle, pulse, laser beam, collider, CERN, TTL, APPG. So this is a continuing series, okay? So thank you for watching, and we'll go on to our next video.